We have given rational fraction and we have to rewrite this fraction to sum of partial fractions. How we do this? First we have to check the power of numerator and denominator. In this example we have t to third power and t to third power, so it means first we have to do long division. So our dividend is t cubed minus 2 and divisor is t cubed minus t squared. So how we do this? First, because we have here t squared and here we have t cubed and next is only constant, so first I will fill the term with t squared and t with 0 coefficient, so it will be easier to do division. So let me copy example one more time. We have t cubed first, so next it's 0 t squared and 0 t, and we have negative 2. We have to divide by t cubed minus t squared. Next we have to concentrate only on the first terms of our example. T cubed and t cubed we have. By what I have to multiply t cubed to get t cubed? By 1, of course. So 1 times t cubed is t cubed. And we have to multiply also the rest of our divisor by 1. So 1 times negative t squared is negative t squared. Next we have to do subtraction. T squared minus t squared is 0. We don't have to write. And we have 0 t squared minus negative t squared. So negative and negative give me positive, so we have 0 t squared plus t squared, so this is t squared. And we have to take down the rest, because the power now of our remainder will be t squared and here is t cubed of our divisor, so we cannot do any more division, so we will take down the rest, and 0t, this is 0, so I don't have to write, so we will copy only negative 2. So this is our remainder. And next we can rewrite our example that this is whatever we have on the top is 1 plus our remainder t squared minus 2 over, we copy our divisor, t cubed minus t squared. So next we have to copy 1 plus, and we need to factorize our denominator. The power of numerator is less than denominator, so next step is to factorize our denominator. So we have t squared minus 2 in the numerator, and factorize t squared, so it will be t minus 1. So we factorize our denominator, so let me copy our fraction. We have t squared minus 2 over t squared times t minus 1. So this is equal. We have to rewrite this fraction to sum of partial fractions. What we have to do first? We have to check what we have in the denominator. Every factor will be now the denominator of our partial fractions. And because we have here t squared, t is linear factor and t repeats 2 times. We have like t times t. So when we have linear factors that repeated, it means that the possible partial fraction are t plus t squared, and we copy the last is t minus 1. Always when we have repeated linear denominator factors, we have to rewrite that this is t like to first power. We don't have to write the first power. Next is t to second power. If we have, for example, here t to 100 power, it means we have to write in the denominator t squared, next will be t to third, t to fourth, t to seventh, until 2t to 100 power. So now in this example we have only t to second power, so we have like t to first power we don't have to write, and next is t squared. and the last factor we have to copy. And now, because we have here linear factors, so in the numerators we have only constants a, b, and c. So now we need to find a, b, and c. How we do this? We have to get rid of the denominators first. So we need to multiply both sides of our equation by the lowest common denominator. The lowest common denominator is always the denominator of the original fraction, so it will be t squared times t minus 1. We have to multiply both sides of our equation by t squared times t minus 1. So t squared with t squared we will cancel out, and t minus 1 with t minus 1. And we will have only on the left side t squared minus 2. And on the right side we have to multiply every fraction in brackets by this whole expression. Let me do this step by step. So we have a over t times t squared t minus 1. Next we have b over t squared times t squared times t minus 1 plus c over t minus 1 times t squared t minus 1. So now we see that we can reduce square with t, and we have t squared with t squared, t minus 1 with t minus 1, and we have that t squared minus 2 is equal a t minus 1 plus b t minus 1 plus c t squared. Next step, we need to find a, b, and c. We can first check what we have again in parentheses. We have t minus 1. For t equals 1, we will have in parentheses 0. So the first and the second term will reduce, and we can find c. And what else? For t equals 0, we will have only the second term, so we will find b. So first let me find, like I said, c and b. So let's put that t is equal 0. So now we have to substitute t's by 0 in our equation. So it will be 0 to second power minus 2. This is equal a times 0, 0 minus 1 plus b, 0 minus 1 plus c times z 0 squared. So we have negative 2 is equal, will be 0, and the last term will be 0. So we have only b times negative 1. So we will divide both sides by y negative 1, because 0 minus 1 is negative 1. Now we divide both sides by negative 1. So negative 1 and negative 1 we can reduce, and we have that b is equal negative 2 divided by negative 1 is 2. We have b. Next, we have that when t is equal 1, we will have that the first and the second term will reduce, and we will find c. So let's substitute t's by 1 now. So it will be 1 to second power minus 2. This is equal a times 1, 1 minus 1 plus b, 1 minus 1 plus c times 1 to second power. So we have 1 to second power is 1 minus 2 is negative 1, of course. So this is equal 1 minus 1 give me 0. So here will be 0, 0. So we have only c times 1. So c times 1 is c. So we have that c is equal negative 1. We found b and c. Now we have to find a. To find a, we first need to multiply, do multiplication on the right side. So let me copy left. We have t squared minus 2. This is equal. We have at times t, so it will be a t square. At times negative 1 is negative at, plus we have b times t is bt, b times negative 1 is negative b, and we have plus ct square. Now we have to combine the like terms. Left side we will copy. We have at square and ct square. So first I will put constant a plus b, and I will factorize t square. C square, of course, I have here, because we have at square plus ct square, so I can factorize t square. Next we have negative at and positive bt, so again I will factorize t, and first I will write coefficients, so will be negative a in parentheses plus b, and in the end we have b, negative b only. So now let's see what we have here. When the left side will be equal to the right side, coefficient before t square is invisible 1, so coefficient before t square should be equal 1. So whatever we have here, a plus c, must be equal 1, because left side must be equal to the right side. Next we have here negative a plus b times t. On the left side we don't have t, it means the coefficient is equal 0. So we have next equation, negative a plus b is equal 0. And we don't have to write more, because we have bc, so we can from the first equation find a. When we substitute c by negative 1, we will have a plus negative 1, so plus negative 1, c is negative 1, is equal 1. So it means, I will move negative 1 to the right side, that a is equal, will be 1 plus 1, so a is equal 2. So we found a, we have c and b, so we can rewrite our original fraction to sum of these partial fractions. But don't forget about this one. First we have 1 plus, and this fraction, rational fraction, we rewrite to sum of these 3 partial fractions. So we have our original fraction is t cubed minus 2 over t cubed minus t squared. This is equal, like I said, we cannot forget about 1, so we have 1 plus, and now our partial fractions. We have a over t. A is 2, so we have 2 over t plus b. We found that this is 2, so we have 2 over t squared, and we have c. C, we found that this is equal negative 1. So we will have negative 1 over t minus 1. So this is equal, positive and negative, we can rewrite that this is negative, so this is 1 plus 2 over t plus 2t squared minus will be 1 over t minus 1. This is my solution.